In this question, we are given a length. The following diagram shows PQ with length 4 centimeters. So this length is 4 centimeters. From here to here, we have a length of 4 centimeters. And the first length is M. This one is M squared. This is M cubed, M4, and so on. So if we consider this sequence, it's a geometric sequence. We can follow geometric progression here. Geometric sequence, the common ratio is R, and R is second divided by first. So this is M squared divided by M equal to M. So this length is supposed to be infinite, so we can use infinite. Sum of infinite terms in a geometric sequence is given by A over 1 minus R. So if we sum this infinite length, then it is given, which is 4 centimeter. Our first term is M, and we can write it, and the ratio is also M. If we solve it, it would become 4 times 1 minus M, which is equal to M. So it would become 4 minus 4M, which is equal to M. 4 is equal to 4M plus M. So M is 4 over 5. So in question, it is mentioned that the diagram shows RS with the length of L centimeters. This whole length is L centimeters, with L is greater than sequence with sides length n centimeter. It means this length is n, it means its height is also n. If this length is n square, its height would be n square, n cube, n4, n4. Okay. So the area, suppose this is area of one, then area of second figure, area of third, area of fourth. area is length into breadth, it would become n times n. This would be n squared times n squared. This is n cubed times n cubed. This is n4 times n4. So it would become n square, n4, n6, n8. It's a geometric progression in terms of their areas and so on. So we can see our first term, which is a1 of this area sequence, is n square, and r can be calculated by a2 divided by a1, which is n4 divided by n2, which is equal to n2. So we know the first term, we know the r. So sum of infinite areas can be a over 1 minus r. a1, suppose a1 is n squared over 1 minus r, and the given area is now cross multiply 25 times 1 minus n squared, which is equal to 11n squared. It would be 25 minus 25n squared, which is equal to 11n squared. So 25 is equal to 11n squared plus 25n squared. So 25 would be equal to 36n squared. We can find n squared, which is 25 over 36. And by taking square root on both sides, n would be 5 by 6. So now let's see the sequence, geometric sequence in lengths. So from here to here, we can see it is n. From here to here, it is n squared. From here to here, it is n cubed. From here to here, it is n4, and the total from here to here, it goes till L. So we can apply geometric sequence as well. Our A is n, our R is n square over n, which is equal to n. So sum of infinite terms is a over n minus 1 minus r. A is n, 1 minus n, and sum of infinite is L. And we have just calculated n, which is 5 by 6. We can insert here. So it would be 5 over 6 over 1 over 6. 6 is cancelled with 6. We are left with 5. So L is 5.